children of primary 3, once again welcome you to this lesson. Thank you for being on. I want your attention please, such that we go through these two-dimension shapes. Today, this time we are going to look at two-dimension shapes. As I told you earlier, that three-dimension shapes, those are shapes which can stand on their own. When you put it on the surface, it can stand and it can be firm. Whereas these two-dimension shapes, those are the shapes which can stand. When you put it somewhere, it will just fall down maybe. Or, for example, I do have here a two-dimension shape. This is a circle. You cannot maybe put a circle and it stands. Maybe one of the three-dimension shapes that is made by a circle, that is what we call a sphere. A sphere is a three-dimension, whereas here a circle is a two-dimension. The reason why it can't stand. I can give you another example. I do have here what we call a rectangle. This is a good rectangle. This is my rectangle. When you put it on the surface, it will just fall down. Reason why it is two-dimension. Some of the examples of three-dimension, as I told you earlier, this is a cuboid. It is a three-dimension. When you put it somewhere, it will sit down properly and firmly. So that's a three-dimension. A rectangle, we are looking at what we call a rectangle. A rectangle, one of the properties of a rectangle is it has four sides. This is my good rectangle. I have a rectangle here. This is a rectangle. It has four sides. This is 1, 2, 3, and 4. This is a rectangle. It is having four sides. It has two opposite sides equal. This side is opposite to this one. It means that this side is equal to this one. It means these are the two opposite sides equal. Same applies to these sides. This is length, and same applies to width. This side is also equal to this side, because they are the opposite sides. We see that we do have these angles here. They meet at angles of 90. Here you can see that here there is an edge, whereby here there is a vertex or a corner where they meet, and there is an angle of 90 degrees. These two symbols, they show that these two lines are equal to this. This line is equal to this line, and this line is also equal to this line, because this is opposite to this one, and this one is opposite to this one. Yes, we go to a triangle, and that is number 2. A triangle. We do have triangles. A triangle. My example of a triangle is this one. This is a triangle. How many sides does it have? This one of the properties of a triangle. We say here they have said it has 3 sides. Is it real that it is having 3 sides? Let us see. This is 1. This is 2. And this is 3. So it means that a triangle is having 3 sides. It doesn't make sense whether they are equal, whether they are not equal, whether some are equal, some is equal to the other one, whether they are opposite. No. So long as they are 3 sides, that is a triangle. We do have very many types of triangles, and we do have 3 types of triangles. There is what you call an isosceles triangle. You find that an isosceles triangle is that triangle whereby this side is equal to this one. Only these two opposite sides, this and this one. It means that is an isosceles triangle. When you find that this side is equal to this one, it means that that is an isosceles triangle. Another one is an equilateral triangle. When you find a triangle, when this side is equal to this side and it is equal to this side, it means that is an equilateral triangle. Another type of triangle, we do have what we call a scalene triangle. A scalene triangle. Scalene triangle is that triangle whereby each side is equal to itself. This side is not equal to this one, and it is not equal to this one. Each side is having its different measure. And that is a scalene triangle. So the point that we should take here is that a triangle is made up of 3 sides. That is the point that we should take. Before going any further, let us first look at some of the lines of folding symmetry. A rectangle, how many lines of folding symmetry does it have? We can see that this rectangle, this is a rectangle that I showed you. Lines of folding symmetry, it means that when you fold that rectangle, how many lines will you get in the middle of that shape when you fold it? So, and when you fold that rectangle, you have to make sure that it becomes equal on either sides. For instance, this is my rectangle. If I fold it once, I have, this is once. If I fold it the second time, will it become equal again? This is once. I fold it. Don't fold it again like this. You fold it next time like this. Will it be equal? Yes, it becomes equal again. So it means that I have folded this rectangle 1 and 2. It means that this rectangle is having 2 lines of folding symmetry. The first line crosses like this, and the second line crosses like this. It means that the rectangle is having only 2 lines of folding symmetry. Yes, we can go to the triangle. How many lines of folding symmetry does it have? When it is, there are some triangles when it is an equilateral triangle. An equilateral triangle is that triangle which is equal. All sides are equal. When you find a triangle like this, and it is having this side equal to this one, equal to this one, it simply means that this triangle, since the 3 sides are equal, it is having again the 3 lines of folding symmetry. This is 1, this is 2, and this is 3. When you find that a triangle is having 3 sides equal, this is my triangle, but this is not an equilateral triangle. But if it was an equilateral triangle, you would fold it like this once. Fold it another time here, it becomes twice, and you will fold it another time, it becomes 3 times. So you will find that there are some lines that are making in the middle of this triangle. This is 1, this is 2, and this is 3. So it makes an equilateral triangle having 3 sides, 3 lines of folding symmetry. An equilateral triangle having 3 lines of folding symmetry. But if it is an isosceles triangle, whereby this side, for instance, this side is equal to this side. If this is an equilateral triangle, rather, if it is an isosceles triangle, only this side is equal to this side, but it is not equal to this side. We say this is having only 1 line of folding symmetry, and that line will just come once. It will be only this line that comes from top to the base. If it is isosceles, it is having 1 line of folding symmetry. If it is an equilateral triangle, it is having 3 lines of folding symmetry. But if it is a Scalene triangle, remember I told you that each and every side is equal to itself. It means that a Scalene triangle does not have any line of folding symmetry, because when you fold, you will see things are not coming up properly. This side doesn't become equal to the other side. So it means that a Scalene triangle is having no line. A Scalene triangle is having no line, no line of folding symmetry. An equilateral triangle is having 3, and an isosceles triangle, it is having 2 lines of, rather, it is isosceles triangle, it is having 1 line of folding symmetry. Isosceles 1, equilateral 3, a Scalene triangle, no line of folding symmetry. We go to a square. A square, this is a square. One of the properties of a square, it has all 4 sides equal. It has all 4 sides equal. This one is equal to this one is equal to this one is equal to this. How many lines of folding symmetry does it have? I have my square here. This is my square. This line is equal to this one, is equal to this one, and it is equal to this one. How many lines of folding symmetry does it have? When I fold it once, this is once, it becomes equal. It means that is one line of folding symmetry. Thank you. When I fold it another time, I'm going to fold it this. Another time, it also becomes equal. It means those are two lines of folding symmetry. I'm going to fold another time. This is 1, this is 2. I'm going to fold it like this to see whether they are going to be equal. When I fold it like this, I'll see. When I fold it like this, I'll again get something which is equal. It means you can fold it properly and it makes something like this. How many so far? How many lines are there? We shall count. How about when I fold it like this also? It will also give me the line of folding symmetry. Now after folding, how many lines are there? When you try to count, you will see that there are 4 lines of folding symmetry. This is 1, this is 2, this is 3, and this is 4. Those are the so-called lines of folding symmetry. So for a square, we'll have this line, and that is 1. We'll have this one, that is 2. We'll have this one, that is 3, and we'll also have this one, that is 4. So it means that a square has 4 lines of folding symmetry. So a square has 4 lines of folding symmetry. Whereas a rectangle is having lines of folding symmetry, and I have also talked of a triangle. Here is our square, rather it is our circle. How many lines of folding? We can talk of also lines of folding symmetry for a circle. A circle is having how many lines of folding symmetry? This is my circle. It is my circle. How many lines? When I try to fold, this is 1. That is 1 line of folding symmetry. If I try to fold it again, I'll get how many lines of folding symmetry? These are 2 lines of folding symmetry. Can I fold another time? So we can see that a circle is made up of many lines of folding symmetry. Again, you will not come across any question saying how many lines of folding symmetry does a circle have. So a circle is having many. You will see that a circle you can fold a circle many times and you get the lines of folding symmetries. We can see here a pentagon. A pentagon is a 5-sided figure, or a 5-sided, yes, it's a 5-sided shape. It is having 5 sides, 1, 2, 3, 4, 5. That is a pentagon. Others we shall see hexagon, heptagon, and others. Those are some of the shapes which we've seen today in primary 3 lesson. My good children, thank you very much for being attentive. Please, if you have any question, forward that question to the responsible people, or you can send it via WhatsApp. Anything, I'll make sure that I answer that question properly. Thank you very much. Meet next time.